welcome to my channel. Today we are going to discuss about laser. Okay, that is module 5. This is for K2 Engineering Physics B session. Okay, Engineering Physics B portion ആണ് laser എന്നുള്ളത്. So let's see what is the full form of laser. It is light amplification by stimulated emission of radiation. Laser the full form ആണ് light amplification by stimulated emission of radiation. L stands for light, A stands for amplification, S stands for stimulated, E stands for emission, and R radiation. Okay, the first successful laser was developed by Theodore Maiman. The first laser ഏതാണെന്ന് ചോദിച്ചാൽ that is ruby laser. It was developed in 1960 by Theodore Maiman. Okay, now what is the use of this laser, or why it is used rather than other type of conventional bulbs and anything else? മറ്റൊരു ലൈറ്റിംഗ് സെഷൻ അല്ലെങ്കിൽ ലൈറ്റിംഗ് ഓബ്ജക്ട്സിനെ നമ്മൾ യൂസ് ചെയ്യാതെ ലേസറിനെ എന്തുകൊണ്ടാണ് നമ്മൾ യൂസ് ചെയ്യുന്നത്? പല കാര്യങ്ങൾക്കും നമ്മൾ ലേസർ യൂസ് ചെയ്യുന്നുണ്ട്. There are so many applications including medical applications, industrial applications, research applications, etc. etc. So why these lasers are important? അതിനാണ് നമ്മൾ ഇനി അടുത്ത് പറയാൻ പോകുന്നത്. The properties of laser. Okay, what are the properties or what are the characteristic features of laser? There are mainly 4 points, that is high degree of coherence, very high directionality, high degree of monochromaticity, very high beam intensity. എന്താണ് 4 points ആണ് the properties of laser. That's an important question that can be asked in your competitive exams or something like that in your future. എന്തുകൊണ്ടാണ് ലേസർ എന്നുള്ള ഒരു ലൈറ്റിംഗ് സിസ്റ്റം നമ്മൾ യൂസ് ചെയ്യുന്നത്? Because of its high degree of coherence, very high directionality, high degree of monochromaticity, and very high beam intensity. So these 4 are the points related to laser. Why a laser is much better than other lighting systems? എന്താണ്? They have high degree of coherence and high directionality. Direction നമുക്ക് ക്ലിയർ ആയിട്ട് ഐഡൻറ്റിഫൈ ചെയ്യാൻ പറ്റും. That's why they are used in laser shows or etc. in എന്താണ് amusement parks and all. Laser shows are there അല്ലേ? laser show ഉണ്ട്. എന്തുകൊണ്ടാണ്? We can see the path directly and it can be used for different shapings. Okay, different structures കാണിക്കാനായിട്ട് we can use this laser. And directionality means it is used in a machine gun and all to point out അല്ലേ? ഒരു പർട്ടിക്കുലർ പോയിന്റിൽ നമുക്ക് എയിം ചെയ്യാൻ വേണ്ടി ആ ഇത് കാണുന്ന പോയിന്റ് എന്ന് പറയുന്ന റെഡ് ലൈറ്റ് എന്ന് പറയുന്നത് that is also a type of laser. So that's why we call it as it have high directionality. Okay, and monochromaticity means it is only of single wavelength, and very high beam intensity means it is having very high intensity. Okay, so these are the features of laser. Next, there is a principle, working principle of laser, as in it is in the name itself. Laser, you know the full form of laser, that is light amplification by stimulated emission of radiation, and then as in the name itself there is a stimulated emission word. അതാണ് നമ്മളുടെ ലേസറിന്റെ പ്രിൻസിപ്പിൾ. That is the principle of laser itself. What is it? It is acting with respect to or in terms of stimulated emission of radiation. Actually, we know when a light falls on a system, there are 2 processes taking place. One is absorption and the other one is emission. Okay, in terms of laser, we consider 2 types of emission, that is spontaneous emission and the stimulated emission. Laser working is due to the stimulated emission. Okay, so what is the principle of laser means? It is stimulated emission of radiation. For human eye, the wavelength range is 400 nanometer to 750 nanometer, which is known as visible region. So remember, which is the visible region for human eye? It is from 400 nanometer to 750 nanometer. Amplification in laser means amplification in laser means amplification of radiation from UV to IR region or IR range of electromagnetic spectrum. Okay, 2 photons will be distinguishable only when they are at different photon states. Now there is an energy level compared to this emission process. We need to explain about energy level. According to quantum ideas, atoms, ions and molecules possess certain discrete energy levels, and these energy levels are known as, or these energy levels are called energy levels in the discrete energy levels are called the energy levels in laser. When radiant energy is given to a system of atoms or molecules, two kinds of transition are possible. Atoms in the ground level may absorb radiant energy and undergo transition to higher energy levels, and such transitions are called excitation transition. Atoms in the excited level may undergo transitions to lower energy level on finding a radiation. Such a transition are known as de-excitation transition. That means we know when a light falls on a system, it can absorb the photons, it can absorb the energy, and that process is called absorption, right? And after acquiring certain energy, it have a tendency to move from the ground state to the higher excited state. So that process we call it as the excitation transition, that is moving to the higher excited state level from the ground state. After staying there for some time, the particle or the atoms or molecules have a tendency to release energy and move towards the ground state. That process is called de-excitation transition. Okay, so these are the different energy transitions taking place in a system. Now let's see absorption and emission of radiation. Atoms will be unable in the excited level. Okay, we all know that in your smaller classes we have studied it. After absorbing, it moves to the excited state level, and that area it may be unstable for some time. They remain in the excited level for a very short time of the order 10 raised to minus 8 seconds, after which they will fall back to the ground level. After remaining in that excited state level, they will move back to or return to the ground state level after attaining a time of 10 raised to minus 8 seconds. It can only stay in that excited level up to 10 raised to minus 8 seconds. So the average time, that is delta T, for which an atom remains in an excited state level is known as mean lifetime of that level. At N1 very much greater than N2, radiated energy h nu equals E2 minus E1. The rate of absorption, which is equal to the rate of excitation transition, is proportional to the number of atoms present in the ground level. That is, dN1 by dt absorption is proportional to N1. Okay, so to remove this proportionality sign, we can write dN1 by dt on absorption case, that is equal to W1 to 2, that is ground state to the excited state, the next level. Okay, 1 to 2 N1. This W12 represents absorption probability for transition from the level 1 to 2. So dN1 by dt on absorption is equal to B12. This W12 has a value, that is B12 into N1 rho. That is, B12 is Einstein's coefficient of absorption, and rho is the number of photons crossing unit area per unit time, that is incident radiation energy and density. So W12 means it is absorption probability, and it has a quantity, that is B12 rho, Einstein's coefficient of absorption into the number of photons. Okay, but remember this equation, because there can be question like Einstein, write down the Einstein's coefficient of absorption, adepole Einstein's coefficient of emission and all. Okay, so we need to remember these equations. Now actually there are two processes, that is emission process. Emission processes are of two types, spontaneous emission and stimulated emission, as already I mentioned earlier. What do you mean by spontaneous emission? As the name itself, it is taking place spontaneously. Okay, let's see what happens. The emission of photons by the natural de-excitation transition of atoms, molecules, ions, etc. is known as spontaneous emission process. The emission of photons by natural de-excitation transition. Normally ആ ഒരു സിസ്റ്റത്തിനകത്ത് നാച്ചുറലി ഒക്കർ ചെയ്യുന്ന ഒരു എമിഷൻ പ്രോസസ്സാണ് സ്പോണ്ടേനിയസ് എമിഷൻ പ്രോസസ്സ് എന്ന് പറയുന്നത്. Can act spontaneously, okay, by natural de-excitation transition. This is an uncontrolled and natural phenomenon in which excited atoms emit photons independently in random direction, phase and polarization. That means when the atom or ions are at the excited state level for 10 to the power minus 8 seconds, they remain there up to 10 raised to minus 8 seconds. Now then they can undergo a de-excitation level, that is they can return to the ground state after that time. So So that is a natural process. That type of uncontrolled process we call it as spontaneous emission. Now the rate of spontaneous emission is proportional to N2. Okay, here the condition is N2 is very much greater than N1. N1 and N2 are the number of particles in the ground level and excited level. N2 represents the number of particles or number of atoms in the excited level, and N1 represents that in the ground level. So rate of spontaneous emission is directly proportional to N2. അതായത് excited state level നിൽക്കുന്ന particlesന് proportional ആയിരിക്കും. That means I can write the equation as dN2 by dt is spontaneous emission proportional to N2, or on removing that proportionality sign, dN2 by dt spontaneous is equal to A N2, where A is Einstein's coefficient of spontaneous emission. So as earlier slide we studied B12, right? That was Einstein's coefficient of absorption. Here we call it as Einstein's coefficient of spontaneous emission, which is represented by the letter capital A. Clear? Now there is another one, stimulated emission. That is the process of de-excitation transition with the emission of radiation on finding an identical radiation as stimuli to trigger the emission. ഈ എമിഷൻ പ്രോസസ്സിന് എക്സ്റ്റേണൽ എനർജി അപ്ലൈ ചെയ്യുക അല്ലെങ്കിൽ എന്തെങ്കിലും ഒരു സ്റ്റിമുലേഷൻ കൊടുത്തിട്ട് അതിനെ ട്രിഗർ ചെയ്യിക്കുകയാണ്. ആ എമിഷൻ പ്രോസസ്സിനെ ട്രിഗർ ചെയ്യിച്ചുകൊണ്ട് ഡി-എക്സൈറ്റേഷൻ ചെയ്യുന്ന സമയത്തിനെയാണ്, ആ പ്രോസസ്സിനെയാണ് നമ്മൾ സ്റ്റിമുലേറ്റഡ് എമിഷൻ എന്ന് പറയുന്നത്. ആസ് ദ നെയിം ഇറ്റ് സെൽഫ്, ഇറ്റ് ഈസ് സ്റ്റിമുലേറ്റഡ് by triggering the atoms or ions. Okay, so stimulating radiation, from the figure you can see that is the particles in the excited state are undergoing de-excitation by after applying or after entering that stimulating radiation. ഒരു റേഡിയേഷൻ അവിടേക്ക് ഒരു ഫോട്ടോ എനർജി അങ്ങോട്ട് അപ്ലൈ ചെയ്ത് കൊടുത്തു. അങ്ങനെ വന്നപ്പോഴാണ് അത് de-excitation ട്രാൻസിഷനിലേക്ക് വരാനുള്ള കാരണമുണ്ടായത്. ആ പ്രോസസ്സിനെയാണ് സ്റ്റിമുലേറ്റഡ് എമിഷൻ എന്ന് പറയുന്നത്. So here also that rate of stimulated emission is directly proportional to N2, or dN2 by dt stimulated is proportional to N2, or dN2 by dt stimulated is equal to W21N2. And it can be written as dN2 by dt stimulated is equal to B21, that is the higher state 2 to 1 ground state, N2 rho. Here B21 represents Einstein's coefficient of stimulated emission. So B12 represents Einstein's coefficient of absorption, A represents Einstein's coefficient of spontaneous emission, and B21 represents Einstein's coefficient of stimulated emission. Okay, so I hope this is okay for all of you. I think there are some questions we have discussed today. That is, one is, what is the full form of laser? What are the properties and features or characteristic features of laser? And the next question was, what is the difference between spontaneous and stimulated emission? I hope these three questions are clear for all of you. If you like this video, please share, like, comment and subscribe. Thank you for watching. Stay safe.